My name remains Pelumi. The class of this morning is going to center around JSS1 and JSS1 class. Some of the topics in mathematics, they are more or less revision of majority of the topics they have done in primary school. So basically, you can say JSS1, but the topic that we are going to look into will be across JSS1 and JSS2. As we have the topic, in the scheme of work for JSS1, we only have it for JSS2. That's why I'm writing for JSS1 and 2. Ordinarily, first topic supposed to be notation, but the notation in JSS1 has been seriously dealt with in the basic, that's primary 4 and primary 5, 6 video. So if you check the last two videos, you see the notation has been dealt with. That is, the notation has gone up to quadrillion. Now, what we are going to look at is we are going to look at least common multiple, that is generally known as what LCM. So that's the next topic. So notation, the LCM and HCF stuff. So if time permits us, we may go into HCF. Now LCM, least common multiple, or we call it what? Lowest common multiple. So it's just one of the oldest topics before the time of colonization, or during the time of colonization of that time. Then least common multiple or lowest common multiple, it's approached from different angle, and different question may pop up from it. Standard one and fairly one. Now let's quickly go into, we have first method. We are going to rush through. Now, when you want to take them least common multiple, the first thing that you look at, like you are starting from the back, you are starting to put them, what is multiple? Ordinarily, it comes out in their bucket to multiple. What is multiple? Now, we said multiple is when the addition of a particular number, that is, the multiple of a number is the addition of that a particular number, or another number that a particular number can easily be divided with. So what are we saying? Multiple is, I said addition or repeated addition of a particular number. I can call it as, I would say, multiple is the repeated addition of a particular number. What do I mean by repeated addition? When I say multiple of 3, multiple of 3, I say, let me say example. Sorry. Examples. I say, write the multiples of 3, maybe to 10 number or so. So multiple of 3, we are going to include 3. Why? 3 can divide 3. So you will add 3 to 3, it will give you 6. So 6 is also multiple of 3. Add 3 to 6, 9. Add 3 to 9, 12. Add 3 to it, 15. Add 3 to it, 18. And like that and like that. You can see that multiples of 3 is what? Now using multiple method. Let's now use multiple method and the first method to look for LCM. Let me call it to say find the LCM of, take for instance, we say 3 and let's say 3 and 4. So when you are starting or you are teaching the kids, you are teaching LCM in primary, you need to start from smaller number. Likewise, secondary, because you don't even know where these kids are coming from. Different schools, and they have different orientation. Now let's move the LCM of 3 and 4. Using the method, first thing you will look for the multiple. That's the first one. Multiple. We look for the multiple. Say find their multiples. Of the two number, they ask us to look for the LCM. So multiple of 3, we have 3, we have 6, 9, 12, 15, 18, 21, and like that. Then multiples of 4, we have 4, we have 8, we have 12, we have 16, we have 20, we have 24. So we have 4, 4, 24, and I think 28, and like that. Now, after you have gotten the multiple for the 2, we have fulfilled this. Then we'll go to common multiple. You look for the what? Common multiples. What are the common multiple out of the 2? We think 12 is common. Do I see anything common again? I think if I move forward, I'll see what is common. Let me move forward here. Here, I think I have 24. After 24, I have 27. Okay, 27. I have what? I have 30. I have 33. I have 36. And if I move here, I have 20, 32. After 32, let's add 4 to 32. We have 36, and like that. So if you now look at it, you see that 36 is also what? Common. So we have 12. Thank you. 24 is also common. So we have 12, 24, and 36. Like I said, my cameraman, my camera boy, is also a student in Jss1, so he knows some of these things. And when he see me going to the other side, he's like, Now, let's move on. We have these 3 to be our multiple. That's common multiple. Then we now move, we have fulfilled this now. So we started with this. Look for the multiple, next common multiple, then the lowest. We now go to the LCM, which is the lowest out of them. That would be what? 12. So our LCM is what? 12. So there's one method for solving LCM. Now let's go to the second method. We say second method. So second method now, the first method here, where is it? Okay, the first method, let's call it multiple method. Let's call the name multiple method. Since we are going to look for the multiple, that's why I call it multiple method. Now, this second method, we can call it prime factor method. Why I call it prime factor method is that I will be using prime numbers, prime factors of those number. Now here it is encouraged that teacher teach the children what is the meaning of a prime number, so that there we could define that prime number is a number that can only be divided by one and what itself. So we have example of prime number. 2 is a prime number. Don't make mistake. 1 is not prime number. We said 1 is odd number. 1 is an odd number, is natural number, is an integer, but it's not a prime number. Why? One prime number can divide by 1 and itself. So you say 1 and 1? No. So 2, we have 3, we have 5, 7, we have 11, we have 13, and like that. So these are the numbers, the prime numbers that we are going to use to solve this method. So later, when we get to Hcf, I can be talking about, I'll teach you prime factors. So let's solve equally with the other one. You have to find the LCM of 3 and 4 using the second method, 3 and 4. So we could use that free method that we used to. Now, I'll take any prime number starting from 2. If 2 can divide any of them, then I use 2. Until I exhaust 2 before I start going for the one that can divide the next one. Now, see that 2 can divide 4. So 2 in 3, that is not possible. I'll let the 3 remain. 2 in 4, 2. Since there's something that 2 can still divide there, I'll still make use of 2. 2 in 3, I will let 3 be, since 2 cannot divide it. So 2 divided by 2, and that is 1. Now I am left with what? 3. After 12, I've exhausted this, I can go to this. If not this, I go to this. If not this, I go to this. So 3 divided by 3, 1, 1. So when the last number turns to 1, 1 there, it means I have gotten my prime. These ones, they call them prime factors. We call them prime factor. Now, I want to bring out 2 things here. Prime factors of the 2. So it's just 2 times 2 times 3. These ones, they are prime factors. Prime factors, we call them. So prime factors for one number, but that's not where we are going to. It's not the prime factor that we want to do, but rather LCM. So our LCM, we just multiply our prime factor. So 2 times 2 times 3. 2 times 2, 4. 4 times 3, that is 12. If you see that we are getting the same answer, both the first method. But to me, this is the I think one F. My own preferred method. Why? Because this prime factor method of LCM can solve big number, while this multiple method may cause problem, because generating the multiple maybe somehow give us problem. Let's look at second example. Example 2. It now say find the LCM of let me say LCM of 9, 12, and let's say 18, so that it's getting bigger. So if I use the second, I want to use the second method. 9, 12, 18. Like I said, I will use my prime number to divide. since there's something there that 2 can divide, 2 can divide numbers with even numbers. So 2 cannot divide 9, it remains. 2 can divide this 6. 2 can divide this, I think that is 9. 2 can still divide one of the numbers. 2 can still divide one of the numbers. So 2 can divide 6 to be 3, and 9 remains. Now we can go for 3. After 2, you can go for 3. 3 can divide 9, 3. 3 can divide 3, 1. And then 3 can divide 9 3 times. So 3 can divide 3, 1. 3 can, 1, this is already 1. And 3 can divide 3, 1. What I mean by divide is, how many 3 can I get in 9? Now I can get my LCM to be equal to, I'll multiply this thing, 2 times 2 times 3 times 3. 2 times 2, 4. 4 times 3. So if you are teaching, let the kids answer you. Ask them 2 times 2. So 2 times 2 is 4. 4 times, let them answer you. 4 times 3, 12. Then 12 times 3, and that is what? 36. So 36. Now for JSS1, we have no option. Given all this one, they are just like simple question. Let me now give a more taxing question. Let me use it an example. It may come in form of word problem. He said, if a ball bounces, am I correct with the spelling of bounces? Bounces. Okay, don't let me say a ball. Let me say if 3 balls bounce alternatively. Let's say alternatively. The first ball will land every 5 minutes. The second let's just say the second 10 minutes, and the third every 15 minutes. And I ask, at what time will the 3 ball will the 3 ball bounce or land? I say bounce. Land together. That is, you have 3 balls. One always bounce or land on the floor for every 5 minutes. This one, the second one, every 10 minutes. Will come down every 10 minutes. The third one, every 15 minutes. There will be a point where all of them will land, we hit the ground at the same time. So if they ask you, sir, that is, what point will the 3 number have what similarity? So of course, if you see this type of question, what they are asking is what the LCM. That's it. Another way of asking you the LCM. That at what time will three of them land? So let's look at the solution. So the first ball, 5 minutes. Second ball, 10. Third one, 15. Let's say at what time will they land? Now I want to divide through by my prime what numbers. Now the prime numbers 2 can divide 10 here, so I'll make use of 2. But 5 remains. This will now be 5, then this will be 15. 2 cannot divide. Then I move to 3. 3 cannot divide 5, but can divide 15 to be 5 times. Then 5 can what? Can make division. And that would be 1, 1, 1. There, my LCM of it will be equal to 2 times 3 times 5, and that will give me, this one will be 6, that's 30. So I have not answered the question. I have just passed through the door, the back door. Now let them see me inside. I'll say the 3 balls will land every 30 minutes. Once it's 30 minutes, all the 3 balls will hit the floor and move back. So these are the types of questions that at least Js1 and Js2 should be expecting. So at this juncture, we like to draw the curtain and give what class tags. Just class tags. Like I said, mathematics teacher must cultivate the habits of giving class work and make sure you go through it. Looking at it, oh, the child will say, I understand. It's easy to celebrate that, but let the child to come and put it to practice. It might be very difficult to do. So we said, find the LCM of the following numbers, or set of numbers, or the following set of numbers. 1, let us say we start from the scratch. I say from the 6 and 8. Number 2, let's say 15, 20, and 25. Okay, at this number, I think is what still enough too. Right? So, like I said, subscribe so that anytime we drop video, after this work for JSS1 and JSS2. But JSS2, I'll by evening, by God grace, I'll go through the JSS2 first topic, which will be standard form. So stay tuned. I am once again